Hello everyone, welcome to my channel Coding Together. My name is Vikas Hoja. Today we will see another lead code problem, that is climbing stairs. It's an easy level lead code problem. So let's read the problem statement. That is, you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways you can climb to the top? So we are given with we are climbing the staircases of n steps. So either we can take one step or two steps. So we have to find the number of ways we can reach the top. So let's see two examples to better understand the question. Like if we are given n equal to 2, if the staircase says I have only two steps, so how many ways I can reach the top? So I can take one step and then I can take the another step and I can reach the top, or I can jump directly two steps to reach the top. Now for n equal to 3, I can take one step plus one step plus one step, or I can take first step and then two steps altogether. Either I can take two steps first and then one step. So there are three ways for n equal to 3. So let's see how we can solve this problem. So first of all, we will start with recursion as usual for the dynamic programming. Then we will move to dynamic programming. How we can use dynamic programming. First we'll use memoization, top to bottom approach, and in tabulation in the next video. So for the recursion, what recursion is like, we for recursion we need our recursion formula, you can say, and the base case. So let's think of this problem like this. So when we talk about top to bottom, we always try to break larger subproblems to smaller subproblems, and we try to solve smaller subproblems, and we try to solve smaller subproblems so that the result can be used to solve the larger subproblems. So if it is a recursive, if the problem can be solved using recursion, then we can optimize using dynamic programming. And one of the technique is memoization. Let's try to write down a recursive formula. So if I say that at top of any step, like in how many ways I can reach the top of the step, is equal to the number of ways I can reach n minus 1 and number of ways I can reach n minus 2. So fn equal to fn minus 1 plus fn minus 2, because I can take either one step or two step, right? So again stating, to reach n, the number of ways I can jump to n is number of ways I can jump n minus 1 and number of ways I can jump n minus 2 number of ways. So if we add number of ways n minus 1 plus n minus 2, I will get the number of ways I can jump to n. Why n minus 1 n minus 2? Because I can jump either one or two steps, right? So this will be our recursive formula. So let's see this like this. Let's take an example for n equal to 5. So we have a staircase with 5 steps. So we have to find in how many ways I can reach the top of the staircase, which have 5 steps. Let's break it down into two parts. If I know the number of ways how I reached the step 4, and if I know the number of ways I reached step 3, right? This will be n minus 1, n minus 2, right? Because I will jump either one staircase or I will jump either two staircases, right? Similarly, for F4, and F3. For F4, if I want to know the number of ways how I can reach F4, if I have to break it into the sub problems, the number of ways I reached 3 and number of ways I reached 2. For F3, how many ways I reached the step 2 and I reached step 1. Similarly for F3, number of ways I reached 2, number of ways I reached 1. So these are our base cases. So breaking down our uh, problems, larger sub problems into smaller sub problems, we have reached our base cases. Like for F2 and F1 will be our base cases, because we are given that either we can climb 2 steps or I can climb 1 step. So we know these sub problems, right? So for F1, like climbing 1 step, we only, the number of ways is 1, and to climb a staircase with step 2, we know that it's 2, because for 2 step I can jump 1 plus 1, or directly I can jump 2. So there are 2 ways. So for F2, I'll return 2, F1, I'll return 1 in the backtrack. So F3 will be 2 plus 1, 3, F2 will return 2, F4 will return 5. Here also F2 will return 2, F1 will return 1, and F3 will return 3, and for F5, 5 plus 3, that is 8. So to reach n equal to 5, staircase with n equal to 5 steps, we have total 8 ways. It will have a time complexity of 2 to power n, big O of 2 to power n. How we can optimize this solution? So we'll use dynamic programming memoization technique. So if you see here, F3 is being calculated, F2 is being calculated, F1 is being calculated multiple times. So here we can save our recursive calls. So if we can cache the recursion done for some of those n values, so we'll use this. So we'll use dp of n, where the n represents the number of staircases, and for each staircase, if we have done our recursion before, we'll use that from our cache for the next time to save some recursive calls, and this will optimize our solution, and it will give us order of n time complexity. So let's jump to the coding part. So here we have initialized dp is equal to n plus 1, because it's the n value starting from 1, it's a one based indexing. We'll fill the dp with minus 1, then we'll call the climb helper method, where we'll pass the n and the dp array. So if we have in the cache, if we have in the dp array the value for n, will return dp of n. Otherwise, for if it meets our base condition, n less than equal to 2, will return n. Or lastly, we'll do the recursive call for n minus 1. We'll fetch the number of ways for n minus 1 and number of ways we can climb n minus 2. We'll add up it to the dp of n and we'll return dp of n. Simple dp on in memoization for climbing stairs. Let's run this program. Yeah, test cases are passing. So hope you like this video. For more such videos, please share and subscribe. It will give me motivation to keep going like this. I'm already getting support from you guys. So thanks a ton.